Section 2.2 is on proofs, and proofs is about as classically mathematical of a topic as you can cover. And it's another topic that's not covered in pre-calculus, which is strange, because anyone going on to math in university, you're going to do a lot of proving. Math is all based on proofs. We don't, in math, we don't look at evidence and assume something's true because we see the same thing happening over and over and over. That happens in science, right? If we see something's repeatable in our observations over and over and over, we say, yeah, it's probably true. But that's not the way it works in math. You could view something a million times happening, some pattern that happens a million times or a billion times, but we don't consider it true until you actually can prove that it's always true for every situation. So it's a very high standard that mathematicians have for their work. So what a proof is, it's a step-by-step explanation that uses the following terms, the ones I have down here, these three, to draw conclusions. So it's all based on logic and reasoning. There's no, observation or looking at patterns to come to conclusions. I mean, those are helpful, but you need to use postulates, theorems, and definitions, and logically come to conclusions. So what are these things? Well, a postulate is a true statement, which does not need to be proven. Well, it kind of goes against what I just said. I said everything has to be proven. But basically, you can prove things down to a certain level and just get to a point where things are so basic that you almost can't even prove them at all. So an example of that would be the statement that you can only draw one line through 2 points. So here's a point and here's a point. And if I asked you to draw a line through there, go ahead, picture how you draw that line. And I know what you're picturing. You're picturing a line that goes something like that. And that's the only line there is. And that's what the statement says, is that there's only one line that goes through those 2 points. And that's such a basic statement that we don't even need to prove that one. That can be just taken as, yeah, that's true, for sure. And so you do need to have some postulates when you're proving things. But you try to minimize those. You try to keep them as few as possible. And you make them very, very obvious and very, very simple. Things that people would be, well, that'd be stupid to prove that because it's so obvious. That kind of thing. There's another word for them. They're also called axioms. What a theorem is, it's a result that has already been proven to be true. So that could be something like the fact that in a triangle, all the angles in the triangle, the 3 angles, add up to 180 degrees. Now that can be proven, but you don't need to prove it every single time because it's been proven, it's very well known. You can just refer to that theorem when you're proving other things. You don't have to go ahead and prove something that's already been proven. And the last thing there is definitions, and that's a statement of the exact meaning of a word. You know that. And an example of that could be something like perpendicular line. Okay, if you're going to talk about perpendicular lines, you know perpendicular lines look something like this. Whoops. And you could remind someone when you're talking about perpendicular lines that the definition of perpendicular lines are they meet at a right angle. Okay? Now, here's the sort of questions you're going to have to do. These are all geometry proofs, so they have lines, triangles, circles, stuff like that. And you're going to have to prove some fact. They're going to give you some information. So here's the information they give you in this case, that angle 2 is equal to angle 3. And then you have to prove that angle 1 is equal to angle 4. And that's it. That's all you're given. Okay, so angle 2 is equal to angle 3. So let's just maybe make note of that. This angle here is equal to this angle here. And I've put that little tick to show they're equal to each other. Now, before I go ahead and prove angle 1 is equal to angle 4, I just want to say something. These 2 lines here, the horizontal lines, they look parallel to each other. And you might say, yeah, I could write as part of my proof that those are parallel. But you couldn't say that right now. Why not? Because there's no parallel sign on those lines. You know what the parallel sign is? It's like this. You put little arrows like this to show they're parallel to each other. But we don't have those. So we can't initially, when we first look at this question, we can't say they're parallel. However, the information we've been given here, that these 2 angles are equal to each other, allows us to say that yes, they are parallel. How come? Because these are alternate interior angles. Remember the Z angles? Right? We talked about this before. If you can draw a Z, the angles inside the armpits have to be equal to each other. So those angles would only be equal to each other if these lines are parallel. If the lines weren't parallel, those angles would not be equal to each other. And that's one possible question I could ask here. Prove that these two lines are parallel to each other. And you can prove that because of these angles, which are in the alternate interior position, which are equal to each other. Okay, but that's not what we're actually doing here. We're proving that 1 is equal to 4. So there's usually different ways you could do this, but here's one way that you could do it. I might say something like, one thing you have to do first of all is you have to say angle 2 is equal to angle 3. Now, how do you know that's true that angle 2 is equal to angle 3? Because it was given to you. So you write given. That's the reason that you can say that. It was given to you. I know that's ridiculous. You're like, what? I'm just rewriting what it says there. But yes, you have to. If you're going to prove something completely, you have to say, how do you know every single statement you're making? And the way I can say this statement is because that information was given to me. Okay, statement number 2 I'll make. Again, there's different ways to do this. You could do it in different order or whatever. I'm going to say that angle 1 plus angle 2, what can you tell me about angle 1 plus angle 2? They are equal to 180 degrees. How come? Because this angle right here is half a circle, and angle 1 and angle 2 together, half a circle, that's 180 degrees. Okay, sorry, this thing's all messed up right now, so I'll go back to this color. How can I say that angle 1 and angle 2 are 180 degrees? Because angles on a line, right, angles on this line right here are supplementary. Supplementary means add up to supplementary means add up to 180 degrees. So you don't have to explain exactly the way I am here, but you could say something like angle 1 and angle 2 are half a circle or something like that. But this is probably the way your textbook or workbook says it. Okay, statement 3. I'm going to say that angle 3 and angle 4 also equal 180 degrees. How come? Because angles on a line are supplementary, right? You could write exactly the same thing there. Again, we have a half circle here. Okay, next thing, I don't even need to look at the picture anymore. If angle 1 plus angle 2 equals 180, and angle 3 plus angle 4 also equals 180, then we can say that angle 1 plus angle 2 has to be equal to angle 3 plus angle 4. If they're both equal to 180, then they have to be equal to each other. What's the reason to this? Well, we could say that they both add to the same amount, or both add to 180, let's say. Okay, statement 5. This angle 2 equals angle 3. Interesting. So where it says angle 2 here, what I could actually write instead of angle 2 is angle 3. They're equal to each other. So I could write that in there instead. What's that called? That's substitution. I took an equality and I substituted into here. So this is substitution. Okay, last statement here. Statement 6. I have angle 3 on both sides. So think of like solving equations. What could you do if you have an angle 3 on both sides? You could subtract. My reason for here is going to be subtraction. And if I subtract angle 3 from both sides, I'm left with angle 1 equals angle 4. I did it. I proved it. I've proven that angle 1 is equal to angle 4. Is this the only way to do this? No, there's different ways you can do it, and they're totally fine if you want to use a different way. But that's one way you could do it. If you want to look all professional, I don't do this, but it's kind of more old school. But if you want to be more professional about this, you write QED. It's Latin. It means something like, I don't know Latin, something like quod erat demonstratum or something like that. And what it means is that which was to be demonstrated, right? What was to be demonstrated was that angle 1 equals angle 4, and I did that. I proved that angle 1 equals angle 4. So if you want to impress everyone, put QED at the bottom, but to tell the truth, I usually don't do it. I think I don't do it because I don't remember what QED stands for in Latin, and so I never want people to ask. Okay, let's do another one. I have to admit, these examples I've chosen aren't the greatest because they're so similar to each other. I should have picked some others which are much different, but on the other hand, I'm probably going to do this section with you in class, so you probably won't watch this video anyway. Haha. Okay, next one. Given triangle ABC, so ABC right here, with line DCB. There's the line DCB. So they're just telling you that there is a triangle and there's a line, but I mean, you can see that right here anyway. What you have to prove is that angle 4, so this angle right here, is equal to angle 2 plus angle 3. That's what you need to prove. All right, well, there's not really anything you have to write down for given, because the given part just tells you, like, look at this triangle with that line. But, you know, that's pretty obvious. You don't need to write anything down there. So what do I see? Well, one thing I see is that we have a triangle, and what do you know about the angles in a triangle? They add up to 180. So you could put angle 1 plus angle 2 plus angle 3 add up to 180 degrees. And how do I know that? And this is what I was talking about before. This is a theorem that you don't need to prove or anything. You're going to say that the angles in a triangle add to 180 degrees. Now some people might say, well, how do you know that? And you just say, well, that's an accepted theorem in mathematics. You don't need to worry about proving it. We could if you wanted to, if you want to go back an extra step. But for today, we're just going to say angles in a triangle add to 180. And I tell you what, it's totally okay with me if you do stuff like this. Angles in triangle equal 180 degrees. I know it's kind of a drag having to write all these reasons, so if you want to get fancy and write with symbols like this, that's okay with me. You probably shouldn't do it if you're doing these at university, but hey, we're just Foundations 11 people. Okay, so next, what can I say about, why would I have angle 4 here? What could I do with that? Well, what I notice, again, very similar to the last one, is that angle 4 plus angle 1 equals 180 degrees. How come? Because angles on a straight line are supplementary. Oh, I could have used my angle sign. Angles on straight line are supplementary, or you could say add to 180. Alright, and then as I said, this question becomes virtually identical to the last one we did. They both add to 180. So then you know that the first one, angle 1 plus angle 2 plus angle 3, has to equal this one, angle 4 plus angle 1. How come? Because they both add to 180 degrees. And if you look, you have angle 1s on both sides, which you could subtract. So you get angle 2 plus angle 3 equals angle 4. That was by substitution to get rid of those angle 1s on both sides. And I believe that's what we had to show. Angle 4 equals angle 2 plus angle 3. Angle 2 plus angle... Yeah, it's exactly the same thing. We could put a step in here where we write angle 4 first, and then we would call that the commutative identity of addition or something like that, but I don't think it's necessary. We've shown this, so if you want QED, or leave the QED off and we're done. Alright, the next one, BD, and it has this symbol here. You know what the symbol is? This symbol here is perpendicular to AC. So BD is here, AC is here, so in other words we have a right angle right there. I'll put it big so I don't cover over the 6. Uh-oh, Simone's awake. Looks like I have to finish this later. Okay, I'm back. So we know that BD and AC are perpendicular, so there's a right angle there. We also know that angle 1, which is this angle, is equal to angle 3. So this angle is equal to that angle. And what we want to show is angle 2 is equal to angle 4. Alright, so first of all, we've got some given statements that we need to make reference to. So my first statement will probably be that BD is perpendicular to AC. And how do we know that? It's given. And we could also say that angle 1 is equal to angle 3. That's also given. Okay, next. Again, there's different ways you could do this. But one thing I see is when two lines are perpendicular, you get a right angle. Well, you actually get more than one right angle. If this is a right angle, this is also a right angle. So I know that angle 5 equals angle 6, and for that you could say both are 90 degrees, or I suppose you could say that perpendicular lines meet at a 90-degree angle. You could probably explain it that way too, but I'm going to say they're both 90 degrees. And now it's going to become similar again to the other ones. One thing I could say is that angle 1 plus angle 2 plus angle 5 equals 180 degrees, and that's because angles in a triangle equal 180 degrees. And if you look at the other small triangle here, 3, 4, and 6 also have to equal 180 degrees. So angle 3 plus angle 4 plus angle 6 equals 180 degrees. How do you know that? Because angles in a triangle equal 180 degrees. Okay, now they're both equal to 180 degrees, so obviously they're equal to each other. Angle 1 plus angle 2 plus angle 5 is equal to angle 3 plus angle 4 plus angle 6. The reason for that is that they add to the same amount. I don't remember how I said it before, but that's good enough. Running out of room here. 7. It says here that angle 1 is equal to angle 3, so where I see angle 1 I could put angle 3. It says here that angle 5 is equal to angle 6, so where I see angle 5 I could put angle 6. Just keep all this the same. Sorry, my angle signs are starting to look like L's or something. And so the reason we could do that was substitution. And again, substitution. This is becoming just like all the other questions we did. The last step is you have an angle 3 on both sides, we could subtract those. You have an angle 6 on both sides, you could subtract those. You're left with angle 2 equals angle 4, and the way we did that was by subtraction. And we've done it, QED. So, you know, this obviously looks like a lot of work to show something that seems pretty obvious, but by doing this step by step by step, you're proving that this is absolutely true in any case where, you know, not just in this picture here, but any case where two lines meet and these angles are equal to each other up here. We've proven that in any case like that, these angles, angle 2 and angle 4, will also be true every single time you have a drawing of this sort. So it's pretty powerful stuff, and that's the power of proofs. Okay, good luck with it. It can be tricky at first.